Hello, my name is Charles Talapa. I'm working with Joe Martini, Josh Greenfield, and Gerard Puccini, and today we're going to talk about the Samsung Galaxy Note 7 battery explosions.
All right, so here's a quick framework of our presentation today. Starting off with an introduction, which just talks about the phone's release. We talk about the reports that were done on the battery and the inevitable recall that occurred on the phone. We talk about battery composition, where basically just give a background on how batteries work so that we can better understand why they failed and why they were lighting on fire. We talk about the two manufacturers that Samsung used to get the batteries for their phones and issues that came with them. We talk about the professional responsibilities that Samsung neglected during their manufacturing process and design process. We talk about the relevant engineering ethics from the IEEE Code of Ethics. And then we're going to sum it all up with a conclusion.
So the introduction. On on August 19, 2016, Samsung released the Galaxy Note 7. This phone was promised to be far superior to any phone that they released in prior years. And some of these improvements included facial recognition, overall improved processing power, and a brand new battery. This battery is supposed to be better than anything on the market, but only 5 days after its initial release on August 24th, the first report of battery ignition was received. And many of these reports continued on for many months after. But as more reports flooded in, Samsung initially believed that these explosions could not be at their fault, but instead the manufacturers of the battery. So they immediately responded with recalling nearly 2.5 million Note 7s and switching battery supplies because they believed if they switch battery supplies, all the problems would go away and they wouldn't have any more exploding batteries. But yet this still upset people, and the public believed that they did not perform necessary improvements or quality control steps to make sure they released a nice, safe, and improved battery. And they did all this just for the sake of releasing a phone on schedule to increase profits and brand recognition.
So, before we go into the actual reasons why the batteries exploded, we thought it'd be good to go over how lithium ion batteries work. So, lithium ion batteries are made of just a few main components. It's made up of two electrodes, the anode and the cathode, and they are separated with an electrolyte separator. So, the positive lithium ions travel from the anode to the cathode through the separator when delivering power to a circuit. And we just have a little diagram here showing that process. So from the anode to the cathode through the separator here. And here is a diagram of how the batteries actually looked in the Note 7s. So we have the two electrodes here. The one in the back here is the positive tab, and the one in the front is the negative tab. And they are separated with a electrolyte separator, and they're all rolled together in a pouch and placed in the phone. So, although lithium-ion batteries are generally stable, with a failure rate of about 1 in 10 million. The most common cause of failure in these types of batteries are internal short circuits, or ISCs. So the result of these ISCs are enough heat being released, which could start and maintain other exothermic reactions. So when, say, the separator in the battery has like a thin spot, that could let the two electrodes make electrical contact to short the battery. So these short circuits do release a lot of heat, potentially up to over 100 degrees Celsius. And when these reactions reach that point of 100 degrees Celsius, the film separator between the anode and the cathode starts to decompose, which allows further contact between the electrodes. and the newly introduced compounds that were previously locked in this separator can react with other compounds in the battery, which release, of course, more heat and very flammable hydrocarbon gases, which leads to total ignition of the battery.
So there's a few manufacturing issues with both of the providers of the batteries. So for manufacturing A, the main issue was on the top right corner of the batteries where they would explode. It was not big enough due to the deformed anodes, and there was thin separators. This is what a normal battery should look like, and you could see how there's so much room here, which is non-existent here. It pushes them over, and right here is where they touch, creating a short. These gaps here too, they're too small, making it easier to short the circuit. For manufacturing B, the average was denser, which, if they were to ignite, would cause a more severe reaction. The other issue which plagued manufacturing B was lower quality control, because manufacturing A's batteries, once they were recalled, Samsung wanted to rush out the new batteries so they could have them back on the markets. This caused them to have sloppy welding burrs, which could cause punctures and missing insulation tape. Right here, this line is the puncture, where there is a clear pass through, which isn't existing.
All right. So a significant part of this situation was the company's response, in this case, Samsung. In a report, Samsung actually did acknowledge that there was poor decision making throughout this design and manufacturing process. However, they never took full responsibility for it. Instead, they were trying to transfer most of the blame that they could onto the battery manufacturers, being manufacturer A and B from earlier. The company did release their own investigation of what happened with batteries and the issues with them, the flaws, and what was causing them to catch on fire. And this was backed up by third-party investigations, which also confirmed pretty much the same reason why they were lighting on fire. Yet Samsung was still trying to insist that the manufacturers were at fault, despite the fact that Samsung were the ones who installed the batteries, didn't test the product to make sure that they were good and safe before they were released to the public. And and once they found the problems with manufacturer A, they made the same mistake with manufacturer B, in that they didn't check for issues with the batteries despite having seen it on the first one. And so throughout this, Samsung neglected their professional responsibilities. The company was rushing production in order to stick to their schedule, as they didn't want to lose sales, and they wanted to save time in switching from one battery manufacturer to another. Basically, they were prioritizing a profit over the safety of their consumers. In doing this, they neglected their obligations to practice ethical engineering, and this was exaggerated by the fact that they had multiple opportunities to fix the issues and to even find the issues before before the phones were released to the public. Instead, they failed to do the proper safety testing and didn't take the proper steps, which should have been apparent. If the first manufacturer batteries failed, they should check, but they did not. They instead tried to put the blame onto the manufacturers, saying that the batteries should have been safe, which they should have been safe before they sold them, or Samsung should have made sure that what they were putting into their product, which was expected to be massively popular, they should have made sure that that was safe.
So what could have been done differently? There was a few things that could have been done differently, such as delaying the release date. Samsung could have pushed back the release date to make sure they used proper quality checks of the batteries and checked what the manufacturers do. Since you saw with manufacturer B that the welds were sloppy and they were missing thermal tape. All these things could have been prevented and stopped many phone batteries from exploding. But yet they tried to rush product and increase the amount of product that was out on the market. Samsung also could have included circuitry to prevent current shortages, which we saw with manufacturer A.
Alright, so the IEEE Code of Ethics provides a standard for engineers to follow to make sure they're practicing engineering ethically when they're designing and manufacturing products, whether they be existing or new and innovative. And so there's three main categories in the Code of Ethics, and for this one, the category that pertains most to the situation is the first one, and it's to uphold the high standards of integrity, responsible behavior, and ethical conduct in professional activities. And beneath that, the first subpoint is more specific and it ties to this situation more. And that is to hold paramount the safety, health, and welfare of the public, to strive to comply with ethical design and sustainable development practices, to protect the privacy of others, and to disclose promptly factors that might endanger the public or the environment. And in this case, there was a danger to the public, which was phones lighting on fire. And so naturally that's dangerous in and of itself. However, if it's, say, somewhere like in a plane and the phone lights on fire, that can make the situation even more dangerous. And so phones are being banned from planes and in other places. But they shouldn't have needed to be because they should have been safe beforehand. Not ensuring that the batteries were safe is a failure in practicing ethical engineering, and Samsung is responsible for that.
Some of the conclusions that we came to while making this presentation is that Samsung made avoidable errors during this design and manufacturing while processing their batteries. They neglected to perform acceptable quality controls during the manufacture to ensure safety. Samsung clearly violated IEEE Code of Ethics, and in doing so, they led to the endangerment of their customers.
We have our references for the photos. And we understand some of the figures and text in here might be difficult to read, so we do have a link below the slides. Thank you.